Then we do the dy over dt now. That's the one. So dy over dt is equals to 3 sine theta becomes 3 cos theta. That's all it is, isn't it? So once we know those two, we can actually find the gradient, right? So gradient is now m equals to 3 cos t on top and divided by minus 8 sine 2t. Okay, what happened is, well, at t equals to pi over 6 or 30. I'm not interested in simplifying this. We leave it like that only. Let's see what we get for m. Cos 30 is root 3 over 2. That's a sine 60, which is also root 3 over 2. Those two cancel out. We are left with minus 3 over 8. That's the gradient of the tangent. Be very careful. That's the tangent, right? For the normal is here. Make it upside down and we change sign. We know why, right? m1, m2 story is equal to minus 1. Gradient we got, we need a point now. The point is very important. So we go to the top there, substitute t as 30. Cos 60 is a half, right? That's a half there. Half times a 4, which is a 2. So the x coordinate is 2, good looking number. Sine 30 is also half. So 3 divided by 2. So it's a 3 over 2. So we got the point and gradient. Then we can find equation of the normal now, right? So it should be y minus y1, which is 3 over 2, equals to slope times x minus x1. We are supposed to get a 23. I think we will get. Let's just multiply everything by 6 maybe, right? So I have 6y minus 9. If you times by 6 right through, that becomes a 16 and bracket x minus 2. So we have 6y is equals to 16x minus 32. That minus 9 becomes a plus 9 and we have 16x and minus 23. 6y. But what they wanted was the answer. They were looking for 16x to the left hand side. So we are supposed to show or write in that form. It's very important. Do not leave like that, please. This is how you leave, because the examiner wants you to leave in that form. All right. So that's it. That's the equations of tangents and normals up to now. Okay, we look at, we have done sums based on the equations of tangents, normals, right? We find dx over dt, dy over dt, then one divided by the other, we get gradient, right? Then once we have gradient and a point, we can find equation of the normal or tangent. Just be careful about the normal, right? Make the fraction upside down and change sign. That's it. We finished the differentiation of parametric equations. Now we are looking at the integration, how to find the area under the curves. Okay, that's question number 1 we have here. That's the integration part. Now if we do this, we are through with parametric equations. Integration, I got x equals to t square, y equals to 2t bracket 3 minus t, done. They want us to find integrate y dx, definite integrals please, 0 and 9. Okay, let's see how we do that. We say integrate y, we know, which is 2t bracket 3 minus t dx. So we say dx, that's a 0, that's a 9. Now the question is, we cannot integrate t with respect to x. So we are supposed to change that. So we need a dt here. To get a dt, we can take that and we can find dx over dt, right? So let's do that. Dx over dt is equals to 2t, right? In this, can we make dx a subject and then put that value back in here? There is another way to do as well, right? So dx is actually 2t times dt. Okay, that's what I'm going to do now. Integrate 2t bracket 3 minus t. In place of dx, I'm going to write 2t times dt. So that's a 2t dt, please. Right? Your textbooks show like this. It doesn't matter. Both are same. They give you the integration like y dx over dt times dt. That's what they say, which is nothing but this. Okay. Now, can we use the same numbers? That's the important part, please. Can we use the same 0, 9? The 0, 9 belongs to x, not t. So we go to x and substitute t as 9. See what we get. So we got x equals to, let's do that here, x equals to t square. If you put x as 9, t square is 9, t is equals to 3 only, because the question says t is greater than or equals to 0. So we have t is equals to 3. So the top number is a 3. The bottom one, which is a 0 there, if you substitute 0 in place of x, 0 is a t square, t is equals to 0 again, and that 0 comes back. So the new limits are 0 and 3 because we are with dt, not with dx, please. So we know how to integrate and how to substitute those values now. Integrate, open the bracket, 2 times 2, 4, 4t square times 3, 12t square. 4t square times t is 4t cubed, right? That's all. And dt, we know that's at 3 and 0, and integration all the way, basic one only, so we can do it. 12t cube divided by 3, 12t cube divided by 3 minus 4t to the 4 divided by 4, right? And of course we get the limits as 0 and 3. We all know how to do this now. 3 goes 4 times, 4t cube, and minus 4, 4 cancel, t to the power 4, and the limits are 0 and 3. They are closed brackets, please. Then substitute a 3 there. 3 cubed, 27. 27 times 4, 108. 4 7s, 28. 8 plus 2, 10. Yes, 108 minus 3 to the power 4 is 81. That's one answer. Minus, if you substitute 0, you should get 0. Right? So 81. 8 minus 1 is a 7, right? 9 minus 8, 1. So 17 should be the area under the curve. That's 17 square units. Okay, that's how you do the integration. Just write y value as y value without any change. The dx should be changed to dt. So you just go and differentiate that, make dx subject, so you can get the answer. And just be careful about the limits. Those ones belong to x, these ones belong to t. You want to try one question now? Because you understood, I hope so. Limits are 0 to 25 and y dx. So I do dx over dt first, right? Dx over dt is equals to 8t. That's all. Make dx subject. Okay, so dx is equals to 8t times dt. It's like integration by substitution style. Okay, and now that's all. In place of dx, we can put that, and y value we know. So integrate. At the same time, shall we find the limits as well, please? Right, we go to x only, so that's a 4t square equals to 25. T square equals to 25 divided by 4. T equals to 5 over 2, please. That's the top limit for t. The bottom one, if you substitute as 0, x as 0, t should be 0. So we have integrate. Y value is 5t minus 2t square. And dx, right? dx is 8t dt. And the limits, we know the top one is 5 over 2, right? And the bottom one is 0. We all know how to solve this from here. Let's open the bracket. 5 times 8, 40. T square minus 2 8s is 16. And t cube. We did not integrate yet, please, right? Integrate 5 over 2 and 0. That you know how to do. 40t cube divided by 3 minus 16t to the 4 divided by 4. Got that? 5 over 2 and 0. You should get the answer. Use the calculators, please. You should get the good looking answer, even though it's a fraction. That's question 2. Now, some of them are examination sums, please. Okay. I will leave this question with you. Is that okay? We have x equals to 3 root t, y equals to that, and you are finding y dx. All right. Limits are 6 and 0 for x, please. And if you substitute 6 there, you can find a t value. Let me just do that part first. X is a 6 equals to 3 root t. Then root t will be 6 divided by 3, which will be a 2. Square on both sides, so t equals to 4. So the new limit on top should change to 4. 0, if you substitute, I think that's just 0. So 0 stays as 0. Then you differentiate that, right? Dx over dt is 3 is a 3. That's t to the power a half. So half comes to the front and t to the minus half. Right? Then you make dx subject and you know what to do next, right? So I will leave that with you because I have few more important sums there. Oh, this is the last one, I think. This is last but one. So we have the final exam question in terms of sine and cos. They gave a question like x equals to t square, y is a sine 2t. Great. They want us to find y dx, and the limits are here 0 to pi square over 4. This is right, very strange. And they said it cuts the x-axis at a, find a, that point. We can do that later. First, let's just go and see how to find the area under the curve. Okay, dx over dt, that's what we do first, is equals to 2t. That implies dx equals to 2t dt. That's what I'm going to substitute there. Okay, a little bit back, right, done. Then we need the new limits. X is pi square over 4, so let's do that. T square equals to, substitute the top one for x, pi square over 4. That looks nice because t equals to pi over 4, please. That's the top limit. If x is a 0, right, then t will be 0. So the question now should look like y dx, then the limits should be pi over 2 there and 0. Then that also should change to dt in the end. So that's the story. Let's write integrate y value is a sine 2t, which is on top there, sine 2t. Dx, we already found, dx is a 2t dt, please. So let's write 2t dt. The limits are pi over 2 and 0. We know how to integrate this. The question looks smart, isn't it? Sine theta. No. Wait. This is sine 2t and 2t. There is a times there. Integration by, right? Integration by what? By parts it is, okay? So let me do that here. Or here itself, fine. Let's call that as a u. And that's a v dash, right? So the question looks like integrate u v dash. So u dash should be a 2. And v should be, you integrate sine theta, you get minus cos theta. Do you remember that? Minus cos 2t and divided by 2, please. Right? Chain rule. Let's write the question now. So the question looks like integrate uv dash. So the answer should be uv minus integrate u dash v. If we are able to do that, we are through. So u is a 2t. Let's write that 2t times v is a minus cos 2t divided by 2, the 2's cancel out, and minus integrate u dash is a 2 and v is again that, so times a minus cos 2t and divide by 2 please, dt in the end. So once we got that, the 2's cancel out there, the 2's will go away. We got minus t cos 2t, right? Minus times minus plus. Integration of cos theta is sin theta. So that's a sin 2t, but differentiate, chain rule please, so it's a half. Guys, listen, this is the integration of that. Okay, done. There is no plus c because we have the limits there. Once we get that, we can actually find the area now. The limits we know, that's a pi over 2, that's 0. Let's do that here. I'm substituting pi over 2 please. See what happens. Pi over 2 is 90. Then this is actually cos 180. Cos 180 is a minus 1 and that's a pi over 2. So minus pi over 2 times that's a minus 1 plus half is a half, sine 180 it is, which is 0. So that whole thing is 0 gone. That's one answer. If you substitute 0, let's see what happens. That is 0, sine 0 is 0. So there is no second answer for you. So it's simply minus times minus plus and it's a pi over 2. That's the area under the curve with the limits 0 and pi square over 4 please. This is one of the past exam questions. That's what they asked you. Okay. That's it. So we stop there. Let's look at one more question. I thought I'll stop there, but there is one here. This is also an examination sum which says x equals to sine t and y equals to sine t plus pi over 6. The limit is minus pi over 2 to pi over 2. That's the value of t, lies between those two. The question asked was, find the equation of the tangent at t equals to pi over 6. That's the first one. Second one says, find the Cartesian equation and show that that is equal to this. That's all we have, right? Okay, the first one. At t equals to pi over 6, we need to find the equation of the tangent. So let's go and find dx over dt, dy over dt, right? Dx over dt, as you can see, is nothing but sine theta is cos theta. So that's a cos t. Done. Now dy over dt is also sine theta, right, which is cos theta. So let's write cos, and theta is nothing but t plus pi over 6. By the way, pi over 6 is 30, as you know. Now what we have to do, this is sine theta done. By chain rule, if you differentiate this with respect to theta, you should get 1. So 1 comes in the front, which has no, I mean, it doesn't make any change. Once we got that, we'll find dy over dx. So that divided by that, which is going to be dy over dx. The gradient of the curve, please, is equals to cos t plus pi over 6 and divided by cos t. That's what we have. We don't need to expand. We just need to find the gradient, please. Gradient of the curve at that point. We need at t equals to pi over 6. So pi over 6 is a 30. That's a 30 and 30. So together that will be a 60. Cos 60 is actually half. Divided by, that's cos 30, because that's pi over 6, which is root 3 over 2. So those two cancelled, and the answer I got is 1 over root 3. We are not finding normal, we are finding the equation of the tangent, so we can leave the gradient like that. Then we need a point now, right? To get the point, we substitute t as pi over 6 into those two. So if you substitute pi over 6 there, the x coordinate is sine 30, which is a half. So that's a half there, watch, comma. That's a 30 plus 30, 60. So sine 60 is root 3 over 2. So those are the two coordinates there, x coordinate and y. So we know the point now and we know gradient 1 over root 3. Now we can find the equation of the tangent. Right, so it's going to be now y minus y1, right? So y minus y1 is root 3 over 2 equals to slope, which is 1/3, 1 over root 3 times x minus x1. So it's x minus a half. That's what we have. We can open the brackets first and then times by 2 root 3. Shall we do times by 2 root 3, or let's keep y on the left hand side, okay? Y equals to, open this bracket, so it's 1 over root 3 x minus 1 over 2 root 3, and then transfer this to the right hand side. It will be plus root 3 over 2. These two we can simplify if we want, right? Times by root 3, right? Times by root 3 and a root 3 there. So the final step should look like 1 over root 3 x minus the bracket, please, because that's a 3 root 3 and minus 1. You can put that inside the bracket actually. 1 plus 3 root 3 and divided by 2 root 3. We can leave it like that. That's a root 3, sorry, 3 it is, which comes to 4, right? If you take minus common, actually brackets we don't need, do we? We don't need any brackets there. So this can be written as a 1 over root 3x minus 1, and that is a plus 3, right? So minus 1 plus 3 will be 2. So it's 2 over 2 root 3 comes back to 1/3, say 1 over root 3x minus 1 over root 3. That's the equation. Watch there very carefully. We made root 3, the 2 root 3 is the same. So times the top one by root 3, that becomes a 3. So I have minus 1 and a plus 3, which will be a 2, right? So the 2's actually cancel out. LCM is 2 root 3, please. That's the equation of the tangent. You might have noticed I made a small mistake here. Don't think that I do sums right all the time, right? That's a minus 1 plus 3, as we said. It's supposed to be a plus 2. That's a plus 2, please. Okay, just be careful. Minus 1 plus 3 is a plus 2. All right.